Okay, so we just finished doing a change of integration variables. And remember, we can make any change of integration variables that we like because, changing integration variables does not change the value of the integral. And we've landed up with this equation in the black box. Now, look at the two things that are being set equal to each other. You have the same integration measure in the two terms, so that matches. Then you've got an alpha p in green and an alpha p in blue. You've got an alpha p dagger in green and an alpha p dagger in blue. So if these two expressions are to match each other, the coefficient of the alphas must match and the coefficient of the alpha daggers must match. So what we learn for equality, what this implies is that C lambda P must be equal to Cp. This is the coefficient of alpha P. And also C lambda P star is equal to Cp star. And this is the coefficient of alpha P dagger. Luckily for us, these two conditions are completely consistent. As soon as you match the coefficients of alpha p, the coefficients of alpha p dagger immediately match. So this is the equation that we have to impose. Now, what does that mean? Well, actually, if you have any momentum, you can get to any other momentum by doing a Lorentz transformation. So a Lorentz transformation allows you to get any P from a given K. So by doing a Lorentz transformation, you can get to any momentum from a first given momentum. What that means is, if we are saying C lambda P is equal to Cp, well, we're saying if you do any Lorentz transformation of the momentum, the coefficient is the same as before you did the Lorentz transformation. And what this is telling you is if you plug in any momentum, this coefficient will be the same. So what we're learning is this coefficient is actually independent of P. That's what we've learned from this axiom, that the coefficient Cp is actually independent of P. So let's go and update our field now. So when we do this mode expansion, in fact, we don't need to include the coefficient there. We only need to include a number C and a number C star. And what have we now done? We have also used axiom number 4. So at this stage, we're getting a rather nice complete expression for our field. We know how it depends on X. We know how it depends on the momentum K. We have one arbitrary constant, and we've satisfied all of our axioms except for A1. So the only thing that we have to explore now is A1 satisfied? If so, then we've managed to satisfy all of our axioms, and in the process, we have determined our free scalar field.